All right, last one. We're going to go back and do 11.1 now. And I know that might seem weird to you.
Bryce, you should tell people that that's your, that the IDs that you have, that's your first one.
Oh, that first one. Those IDs are so classic. All right, we're going to talk about tangent lines. You know, tangents, things I go off on all the time. Tangent lines and the derivative.
Oh, yay.
I know. You've heard of this derivative thing, haven't you? Okay. Tangent lines and the derivative. So basically, our whole job here today is I'm just going to teach you the first branch of calculus. Calculus kind of is split up into two branches, and derivatives are the first branch, and then integrals are the second one. Okay? All right, so here we go. Now, back when they invented calculus, two people actually invented calculus at the same time.
How do we know it's real then?
No, it is. They have documentation of it. Yeah, it's pretty cool. So the two guys were Newton and Leibniz. They came up with like how to find. So the whole thing was this: Galileo, back in like 1500s, 1600s, he was trying to find like the velocity at a instantaneous time. Anyone in physics? You talk about velocity a lot? Yeah. So like, for example, if I want to find the rate of change from this point to this point, you can do that by finding the average rate of change by finding the slope of the line that they both go through. But how do you find the slope of a line that only goes through one point? How do you do that? That was the whole thing that they were trying to do. So you can kind of eyeball it. Like, for example, if you're in physics, you know that if you're at a maximum or minimum, what's the velocity? 0. Yeah. So that's what their job was to do. They were trying to find the slope of tangents at any single point. So over here, this is going to be positive because you can tell your object is rising, it's increasing, and it's steeper here than it was before. So that was what the whole thing was about. Okay, so here we go. This is what we're going to do. I'm going to go through the whole way to find it. Okay, so draw this graph. And let's say that we have just a curved graph like this, okay? And we are trying to find the slope of the tangent line at this point right here, okay? We're trying to find the slope of that, the tangent at that point. So this is what they do. They label this point x, f of x. So this is the line or the curve y equals f of x. And what they do is they go a distance of h down the road. So they go a distance of h, and then we get another point on our graph. Okay? So this green right here, that's a distance of h. And this point right here is now what? It's x plus h. And what's its y value? Perfect. F of x plus h. Okay? And so what they do is they go ahead and they find the slope of that line. That red line that I just drew is not the tangent at that red point. This is called the secant line. And I know that these are, gosh, this pen's not working. I know that these aren't, or these are trig terms, but they're not really the trig terms. That says secant. Can you read that? Not really, huh? I don't know what's going on with this pen. All right, let's write it again. Nope. Nothing happened here. All right, so this is called, oh my gosh. It's the secant line. Ooh, there we go. It worked. The secant line. Okay, that's the red line. Now, how in the world am I going to get that secant line to then kind of turn into the tangent line? Well, what you do is this. You take this distance from these 2 points and you keep shortening it, okay? It's almost like you're taking this point and you move it a little bit closer, until finally the points come together as one point and you get the tangent line. Okay? Now the only way we can do that is by taking a limit. That's why I taught you 11.3 before 11.1.
Wait, what? Wait. I don't understand. I understand the secant line is that it goes through both points? Right?
Yes.
Okay, but then what about what are you saying about a tangent line?
Yeah, so you take this point and then you move it closer and closer. So h is shrinking, okay? And as h is shrinking, see, we're trying to find the equation of this tangent line right here, or the slope of it. And so we keep going closer and closer, and we're getting a better estimate each time. You know what I mean? Like if you had this and this, but you're trying to find the rate of change at that one point. And if you did that, is that even close? Not really. But what about if I took it here? Oh, closer. How about right next to it? Closer. How about exactly on it? That's the closest, and that's it. That's exactly it. Now the problem is, though, is that you can't find the slope of one point. Remember, haven't you learned your whole life, how do you find a line? You have to have 2 points to make a line, right? So how in the world are we going to find the slope of that line?
Wait, I'm confused about the 2 points, like moving, or is it just the top?
No, just the top one.
Okay.
Yeah. So we're trying to find the slope at that point, at this point right here.
And that's called the tangent line, even though it has nothing to do with the tangent.
With like sine over cosine, yeah.
Cool.
But you guys, didn't you learn tangents in geometry? If you have a circle and you have this and you find the tangent to it, tangent line. Yeah. It's like here we are, we're walking along, and all of a sudden I go off on a tangent, right? That's what that comes from, really. I do that all the time. Okay, so how are we going to find the slope, or the slope at one single point? Well, how do you find the slope at 2 points? You do y minus y over x minus x, right? But it's usually y1 minus y2, or the other way around, but whatever. But we only have 1 point right now, so how am I going to do that? That was the problem that they were finding. Galileo couldn't do it. He couldn't figure it out. It wasn't until Leibniz and Newton came along that they were able to do it. So here's how you do it. Let's go ahead and take those 2 points that I originally gave you, and let's find the slope of those 2 points, okay? So we're going to do the y minus the y. So f of x plus h. That's the y value of that second point. See, there's 2 points here still, these two. Okay? So f of x plus h minus f of x over the x's. X plus h minus x. Okay? And let's go ahead and fix that. So we end up getting f of x plus h minus f of x all over h. And the way that we find the slope, the rate of change, this is what we're doing. This is all slope. The way that we find the slope at that one single point is we're going to take the limit as h approaches 0. That distance between those 2 points is getting smaller and smaller and smaller until it's 0. Then you can find the slope at that one single point.
There's a lot in my brain.
Yes, it is. And you know why it is? Because I didn't just give you this formula. I showed you how they did it, and that's hard. It's hard to learn what did they do to get there. This is exactly, well, not exactly, but this is what we do to get to this. Now, if you don't like any of that, maybe you didn't understand it, maybe it was a little over your head, you do need to know this formula. So if you want to just accept this formula, that's fine, but I told you why it works instead of just giving it to you this time.
I like that.
Yeah. Okay, so now what are we going to do with this? Yeah.
So this equation is the equation to find the tangent or something?
Exactly. Yes. All right, so this is the equation, or the formula to find the slope of the tangent. Okay? And it's really not going to make too much sense until we do a couple of problems, examples. Okay, and I like to graph them for you and show you what we're trying to find so you can see it visually too. So go ahead and write that down. The limit is the main part, though. I mean, that's huge. Like, they didn't have limits. They didn't know what they were doing. They were trying to find, you can find the average speed, like, for example. Okay. All right, so let's do some. Here we go. Number 1. All right, I'm going to give you a function, f of x equals x squared. The most basic parabola you know, right? And we are going to, by limits, we are going to find the slope of the tangent at x equals 3. Okay? So we have f of x equals x squared. We're going to find the slope of the tangent at x equals 3. So let me visually show you exactly what we're doing, and then we're going to do the formula, and I'll show you how it works, okay? So go ahead and draw your basic parabola. This is just, you know, y equals x squared. It goes through the origin, up 1 over 1, okay? You don't have to really know any of that, just kind of the shape of it. And then if you go to 1, 2, 3, we're up here. I should have drawn it a little bit better. We're at the point 39. Do you agree with that? That's the point 39. Okay. And at that point 39, there is a tangent line that will tell you the exact rate of change at that instantaneous point. When x equals 3, it will tell you the rate of change or the slope of that line. We have to find that slope of the red line. Okay? All right, and we do that by using the formula that I just gave you right there. Here we go. You ready? We're going to do it for the first time. All right, we're going to take the limit as h approaches 0. Make sure you write that every time. Okay, now, there are 3 parts to this formula. There's f of x plus h. Nope, this isn't working. It's too far up there. There's f of x plus h, and then there's f of x, and then there's just simply h on the bottom. There's 3 parts, okay? The part that people don't like is the f of x plus h. Because you feel like you need to plug into the formula, but you're really going to take x plus h and plug it into here. Like if, for example, so here's f of x, right? It's x squared. If I told you what's f of 5, what would you do? You plug in 5, okay? What I need to do is I need to find out what f of x plus h is to do this first part. What is f of x plus h? It's x plus h squared. You're taking x plus h and you're plugging it into this function right here. Just like you would f of 5 is 25, f of negative 10 is 100, f of a is a squared. This is simply f of x plus h, okay? And then minus f of x. Well, what is f of x? They tell you what f of x is. It's x squared. And this is all over h.
And that means all over 0?
Okay, so if you were to try and find the limit, you plug in 0 and you get 0 over 0. Oh no. Okay. So now there's stuff that we have to do. And this is the stuff you learned last week, right? All your algebraic techniques.
Wow.
You're going to do conjugates. You're going to do fractions. This one, you're going to FOIL this out. Combine like terms. Here we go. So we got limit. H goes to 0. FOIL this out. X plus h squared is, do you know the shortcut? X squared. So you square the first term. And then you multiply all the things you see together. 2 times x times h. And then square the last term. Plus h squared. And then minus x squared all over h. This is why we did this last week. We had one on our quiz. What was it? X plus 4 squared minus something, remember?
No.
No?
That's
Okay. You don't remember doing that one on your quiz?
Yeah.
Thank you. Plus 1. Okay, here we go. Now, take those and let's go ahead and do some algebra. X squared minus x squared. What do they have in common up top? H. Factor the h out of it. Okay? H is reduce. This is all the stuff we did, the algebra stuff. H is reduce, and we just got rid of the part where we were plugging in 0 and getting 0 over 0. So now our last step is to actually take the limit as h goes to 0. You're going to take 0 and you plug it in. And you know what you get? You get 2x. Okay, so you're like, okay, what does that give us? That gives us the formula to find the slope of the tangent at any point on x squared.
Oh, no.
Yeah. What point am I looking at, though?
3,9.
I'm looking at the point 39. So when x equals 3, then my slope would be 6. Plug it into your formula. This formula is key right here. That's the thing you want. So if I tell you now, or I ask you, what's the slope at x equals negative 1? You plug in, what's the slope there? Negative 2. You plug it in, that's the slope, negative 2. Okay? All right, so let's talk about this last thing right here. this formula with x in it and all that stuff is called the derivative. That's what that is, okay? So the derivative, write this down, derivative is the formula for the slope. The derivative is the formula for the slope of the tangent at any point. Okay? So once I have that, I can just plug in any x and find the instantaneous velocity or whatever I'm looking for at any single point on that graph. Plug in 0. What should 0 be? What's the rate of change at 0? It's 0, right? You know that. A lot of you physics people, you know that. Maximum minimums. Well, plug in 0 into your formula here. The slope is 0. Do you love it or hate it? Hate it, okay. What's your least favorite lessons of the year? Mine was statistics.
I don't like the ones with numbers in them.
Yeah, that wasn't very many of them. So you liked all the trig stuff when there were no numbers?
The trig one.
Yes, proofs. Love it. Okay, should we do another polynomial or, let's see. Let's do another polynomial.
Let's just do another one.
Another one. So cute. All right, here we go. We are going to, we're going to find the derivative. And those of you going into calculus next year, this is like kind of what we start with. We do limits, derivatives, and this will all, you'll all get this again, okay? We're going to find the derivative. We're going to find the slope at the point 2,8. And then we're going to find the equation of the tangent line. Okay? So basically, what you have is you're going to be given a graph. And we're given a point on that graph, and we want to find the equation of the tangent line that goes through it. And we do that by finding the derivative of it first. Okay, so let's give you one. I'm going to give you a harder one this time. F of x equals 3x squared minus 2x. 3x squared minus 2x. Okay? So if you were to plug in 2 into this function, you would get 8. 2, 8 is a point on that graph. It's another parabola, but it's a harder one. So here we go. Are you ready? We're going to do the whole thing. So we're going to take the limit as h goes to 0. And so here's the hard part. The hard part is f of x plus h. So you take x plus h and you plug it into your function. Okay? So that would be 3 times x plus h squared minus 2 times x plus h. Is anyone stuck on that? No? Like if I wanted to find what f of 2 was, I would plug in 2 in for this x and this x. Now I'm just replacing it with x plus h and x plus h. Okay. Minus f of x. Now be careful here. You have to subtract all of f of x. So if you want to, you can put parentheses around it to remind yourself that I need to subtract both the terms, not just the first term, but both of them. Okay? And then this is all over h. All right, and now we have some algebra to do. 90% of calculus is algebra, and 99% of where kids make mistakes is there. Like the calculus is not the hard part, it's the algebra. Okay, so we're going to take this and we're going to FOIL this out, and then we're going to distribute the 3. Can you do that at the same time? Personally, can you do that? Yeah? Good. All right. So I'm going to FOIL this, so I get x squared, but then times 3. The middle term is 2xh times 3, so 6xh. And then the last term is h squared times 3, so 3h squared.
Wait.
Yeah?
I'm sorry, but in the second one, is that 3 parentheses x plus 1 or x plus
H. Yeah, I plugged in x plus h for both of these reds, but now they're black, so yeah. X plus h gets plugged in. All right, minus, now we have to distribute the minus 2. So minus 2x minus 2h. And then, finally, distribute the negative to all of that. Look how nice this is. Minus 3x squared plus 2x. And this is all over h. Okay. At this point, if you were to evaluate the limit by plugging in 0, you would still get 0 over 0. Okay? So anything up top that does not have an h is going to cancel out. See this 3x squared?
Every time?
Every time. And the negative 3x squared, they cancel out. See this negative 2x and a positive 2x cancel out, and I'm left with every single term has an h in it. It will.
That's great.
Yeah, because now we're going to factor that h to the front. Factor the h out of that thing. So h and then 6x plus 3h minus 2 over h. See, all three terms that were left in the numerator, and they had an h to share, and so then you get rid of that. And finally, yeah?
Wait, in the top part, how did you get that minus 2x minus 2h?
Oh, see, this had two places that I had to plug in x plus h. It was a little more complicated, yeah.
Can you please slow down?
Yes, I'm sorry. Am I? Oh, it's just algebra.
Yeah, you said 90%.
90%, yes, true. Everyone makes mistakes right here. Because you're foiling, you're distributing. You're foiling and distributing at the same time. All right, I'll slow down. All right, they're from lots of different countries, so yeah. Okay, so h equals 0. Plug in 0. Our answer is 6x minus 2. Now, you're wondering, what did we just find? That's called the derivative. We just found the derivative of 3x squared minus 2x.
Wait, what about that 3h?
No, we evaluated the limit by plugging in 0. Your last step, see that last step? See what you're left with? You're left with the limit as h goes to 0 of 6x plus 3h minus 2. Is there any problem with me plugging in 0 now? Nope. I plug 0 in, and I end up with 6x minus 2. Okay, so that right there is the derivative. Now, we want to, so that's part A. Part B is now we have to find the slope at the point, what was the point? It was 2.8? Was it 2.8? Yeah. We need to find the slope at that exact point, 2.8. Okay? So we're going to use our formula, and we're going to plug this in. We don't need the 8 because there's no y in our formula. There's just x, right?
Do we eventually have one?
There could be. In calculus, you do. You're not there yet. That's not until way later. That's when you do implicit differentiation. That's really good. All right, and you get 10.
That's when you get real math goosebumps.
Yes, for sure. That chapter for sure. All right, so you get the slope is 10. Is everyone okay with that? This right here, you guys, this is to find the slope now at any point on that one specific parabola. Any point they give you. It's a formula. You just found a formula. Now, if you give a different point, you can just plug it into that formula. Okay, now part C is finally to find the equation of a line. We just did equations of lines when we did our asymptotes in hyperbolas. And so we have a slope right here. We have a point. So let's put this into point slope form, and you can leave it. You know point slope form? Y minus 8 equals 10, x minus 2. And that would be the equation of the tangent line. Derivative, slope, equation of the line. It's like first chapter of calculus right here. Well, this is pre-calculus. We're getting ready. All right, number 3. So I just did 2 parabolas. Let's do something a little more fun. What do you say? We're going. Oh, as many as I want.
No,
All right, we're going to find.
Do you have more letters or?
No, there's no letters at all today. It's just all one big mess
How many
of
different-
awesomeness. No,
Do you have left?
I don't have any. I'm not even following anything up here. I'm just like I'm winging it. I love it.
Are you serious?
Yes. All right. Find f prime of x, and you're probably like, what's that? That's the symbol for derivative. Okay. Oh, the other calculus. The other symbol for derivative is dy dx. Okay. I believe this is Newton and this was Leibniz. So dy dx came from
Yeah.
the change in y over the change in x. Yeah, if you're in physics, you know that. This is what this is. What are we trying to find today? The slope of the tangent line. What is the slope? It's the rate of change. It's miles per hour. It's how many cookies per second you can eat. It's, you know, it's like it's a rate. Huh?
Didn't we have to do this without using the derivative?
Yeah, but derivatives make it so much easier. And when you get to AP Physics people out there next year, you will be doing it using the derivative.
Yeah, everyone was like, I wish you knew what the derivative was.
Right? Yes. Okay. So here we go. Let me give you f of x equals 1 over x plus 3. Okay. Polynomials are actually really easy to find the derivative. You're going to find out next year. There's a nice, huge shortcut. Some of you probably already know, but for something like this is not a polynomial. It's a rational function. It's a little harder to find the derivative of that. So we're going to do it, doing the limit as h goes to 0 again. Are you ready? Okay. We're finding the derivative. That's what these symbols mean up here. So take the limit, and I'll go slow. As h goes to 0, I have one more after this.
Oh, okay, so we're like second to last one.
Yeah. Yeah. I'm just messing with you. All right, so we're going to do f of x plus h. That's the first part. So it's 1 over, now anywhere you see an x, you're going to replace that with x plus h. So it's 1 over x plus h plus 3. Okay? Minus f of x. F of x is what they give to us, which is 1 over x plus 3. And this is all over h. Okay, that's the first part, bless you. That's just plugging it into the formula, okay? Now, the next part is where you have to use your algebra skills. Algebra is very important for calculus. You're going to need a common denominator in the numerator up here, okay? And so this is why we did this whole thing last week. Our common denominator between these is going to be, we need an x plus h plus 3 and an x plus 3 for both of them. X plus h plus 3 and an x plus 3. Okay, this is all over h still. And now let's go ahead and get our common denominator for this first one. So right here, this already has the x plus h plus 3, but what's it missing? The x plus 3. Over here, this one, right here, the one that's 1 over x plus 3, it's missing the x plus h plus 3. It just like makes me think, how would they think that you can do this? You know, this is 11.1. Why would they put this before 11.3? You know what I mean? I don't know. Okay, so now let's go ahead. The limit as h goes to 0. And let's combine our numerators. We're going to leave that h where it's at on the bottom, but we want to combine this whole top part into one fraction. So don't forget, you're going to take that negative and you're going to distribute it. Okay? So what do we get? Well, our x's will cancel out. They do cancel, become 0. 3 minus 3, and what are we left with up top? Negative h. I'm glad you said negative h. And then on the bottom, we have x plus h plus 3, x plus 3. Now remember, this is all over h still. But I hate fractions over fractions, so what should we do with that bottom? Yes, you're going to take it, because this is really dividing by h over 1. You're going to take it and flip it. Remember, we did this. And multiply by 1 over h. Still, if we were to plug in 0 at this point for h, we'd still get 0 over 0. But once we go like that, we get rid of those h's, we reduce them. You're now going to take the limit as h goes to 0, negative 1 over x plus h plus 3 times x plus 3. And then go ahead. This is where people, they stop. They like got to there and then they stop. You need to now evaluate the limit. Take the limit as h goes to 0 by plugging 0 in for any h's that you see. And the derivative of 1 over x plus 3 is negative 1 over x plus 3 squared. Sweet. Whew, so good. All right, we got one more. I've only done 4 examples.
Is H always going to be 0?
Yep.
We're finding the derivative.
Exactly. You go way back to the beginning of time, and it's right about here. H goes to 0.
Okay.
That's the formula. It doesn't change. That's all we've learned today. Just that.
That's it?
Just that. Just that. It's like Star Wars, huh? Okay. Here we go. Number 4. Last one. Okay. Find f prime of x. We're just finding the derivative. Okay. And then we're going to do like the slope and stuff like that. When f of x equals the square root of x. So we've done 2 parabolas, and we did a rational function. Now let's do a radical. Okay? So we're finding the derivative of this. Here we go. You want to try it on your own? Ready? Not yet? Okay, not at all. Okay, limit as h goes to 0. Okay, so we're going to do, dang it, I didn't win Hamilton. Dang.
You already won.
Oh, I've entered again. It's in Costa Mesa now. It used to be at the Panteaches. So, f of x plus h minus f of x all over h. Are you getting used to that? Because that sometimes is kind of tricky. You're like, what are we doing here? We're plugging in x plus h into our function, subtracting into it. Okay. And we learned last week how to solve these. What are you going to do? No, we're going to do something. We're going to multiply by the conjugate. Thank you. Conjugate. So we're going to multiply top and bottom by the square root of x plus h plus the square root of x. Okay? We did this rationalizing technique last week. So you're used to it. You're really good at it. All right? Take the numerator and FOIL it out. So what do we get? They're conjugates. So you only have to really do the outside, yeah, the FOIL, the FL part. So we get
X plus 8
good
minus
minus x. And then don't do anything to the bottom. When they're conjugates, you just leave the other part alone. Okay, I bet I could like leave you to finish this one.
You know, I bet.
I bet I could. I'm not going to though.
That's good.
Okay.
Like you could leave your kids in the grocery store and they'd probably find you.
Oh yeah, that would suck. Okay, the finding me part. Okay, so now the x's cancel.
And it's 1 over rad.
Yes, and the h's reduce. So you're left with 1 over rad x plus h plus x for rad x. And now, don't forget this step. I'm telling you, people forget it. Take that 0 and plug it in for h. So you end up with 1 over, well, you get a rad x plus another rad x, 2 rad x. And that would be the derivative, okay? Now, if I wanted to find the slope at x equals, I'll give you a nice one, 4, okay?
Wait, why is it?
Oh.
Why is it just 2x on the denominator?
2 rad x.
2 rad x.
So when you plug in 0 for h, you're left with rad x plus rad x. How many rad x's do you have? 2 of them.
3.
2 of them. Okay, so here's our original function, square root function, okay? And at x equals 4, we're going to try and find the slope there. And then we're going to find the equation of that tangent line, okay? So now that we have the formula, the derivative is the formula to find the slope at any point we want on this graph. So now we can go ahead. What would the slope be? 1/4. 1/4. You take that 4 and you plug it into the formula that you just found for the slope. So square root of 4 is 2. 2 times 2 is 4. So 1/4. So this red line right here, you would rise 1, run 4, and that's where you're at. Okay, now let's find the equation. in order to find the equation of that red line, you need a point and a slope. Well, I've got half of a point and I've got a slope. What's the other half of the point? 2. You see that? The point is 4, 2. And if you ever wonder how you find that, you go back to the original function and you find its y value at 4, 2. And then you write an equation for that. Point slope form. Love point slope form. It's always been, it was never my favorite when I taught Algebra 1. And then once I taught calculus, then it was my favorite. There it is. Done. Oh no.